Hello, we're going to talk about a fake lab and its calculations. But first, hey, come back here. Come back here. I want to show you my faithful companion who is sitting here staring at the Oreo cookies I have. So we'll give him a piece of Oreo cookie. There you go, buddy. And then we'll get started. Alright, so we're going to look at the lab that is the second and third page of the heat worksheets I loaded the other day. And what we're going to do, I've got a little video I made at my own stove. It's very exciting of how this lab would proceed. But basically, you're going to be able to cross out those. And you're going to be able, yeah, that's it. Okay? So, watch the little video and see how it goes. Welcome to Crazy Labs with Mama Bush. Alright, for this lab, we are going to take this piece of metal, and find its mass, and its mass, oh look, 100 grams. Write it down. Now we're going to put it in to the pan to heat up. And we're going to find the mass of the water in the cup. And the mass of the water in the cup is 24.5 grams. Okay? Now we're going to take the temperature of our metal. And our temperature of our metal is 110 degrees. And we're going to take the temperature of our water, and the temperature of the water is 20 degrees. Oh, I didn't put it in there. Now it's 20 degrees. And then we're going to dump our mysterious metal in. And we're going to take our temperature. And I don't have a piece of paper, so we're going to pretend like it says 35 degrees. Alright, so you've seen us do our lab. Now we're going to do our numbers. So, the temperature, the mass of the water, let's use a different color, was 24.5 degrees Celsius. The temperature of the water initially was 20 degrees Celsius. The temperature of the metal was 110. The final temperature of the water and the metal was 30 degrees, and the mass of our metal was 100 grams. What do we do with this information? Well, here is what we're going to do. Remember when we talked about surroundings and systems? We said that the heat in a surroundings is given off to the system. So if you have the system is positive and the heat flows into it, then the surroundings are going to be negative. Okay? So we have two systems here. We have the metal and we have water. All right? So if one of those is positive, the other one is going to be negative. So we can calculate Q equals MCAT of both and know that if one of them is positive, the other one is negative. All right, the heat flowed into the water, which means the metal is going to be the negative one. So we're going to have negative Q equals Q. Okay, and what we're going to do is use the information we have to figure out the specific heat of the metal, which will identify the metal. All right, so what was the initial mass of our water? Our water was 24.5 degrees, not degrees Celsius, grams. The specific heat of water, if we look back at our heat worksheets up at the top, the specific heat of water is 4.184. Oops, now I'm erasing. 4.184 joules over grams degrees Celsius, because that number means it takes 4.184 joules of energy to raise 1 gram of water by 1 degree Celsius. And then our temperature change the water started out at 20 and it ended at 30. So it was a 10-degree change. Okay? That's going to be equal to a negative Q, which is the mass of the metal. Mass of the metal was 100 grams. The specific heat is the unknown, so I'm going to label that C. And our temperature change, we went from 110 to 30 degrees, and we lost heat, so we're going to have a negative number. That's a negative 80. And I didn't put my units in there. There's joules over grams degrees Celsius and degrees Celsius. All right, so we've got 80 times 100, which would be 8,000. It's a negative times a negative, so it's a positive. And our units here are grams times degrees Celsius, and that's going to be multiplied by the specific heat, which the units are joules over grams degrees Celsius. And that is going to be equal to the other side. Our multiplication there is 24.5 times 10 times 4.184, 1025. Our grams will cancel, our Celsius will cancel, and we'll have joules. Now we need to solve for C. So we divide both sides by 8,000 grams degrees Celsius, and we get C equals 1025 divided by 8,000. I don't know why I can't remember that zero. And we get 0.128. And our units are joules over grams degrees Celsius. Okay? So let's look back at our heat worksheets and go back to the first one. Do you see something that has a specific heat capacity? That's what I'm looking for, of 0.128. And we do. We have lead that's a 0.128, or it could be gold, 0.129. How would we tell the difference between those two? Well, remember what it looked like? It was a gold color. Probably gold. All right. So, I've got to go back to this page. So, the specific heat is equal to 0.128 joules over grams degrees Celsius, which is probably gold. All right, not to be outdone, we have a second one.
And now for trial 2. Here is our metal, and our metal is again 100 grams. We're going to heat the metal. Here's our water. Our water is 56 grams. The temperature of our water is 25. The temperature of our metal is 90. And the temperature of the metal after it has cooled down the water, or it has cooled down and the water has heated up is 35 degrees Celsius.
All right, let's do the second set of calculations from trial 2. For this trial, the mass of our water was 56 degrees Celsius, grams. The initial temperature of our water this time was 25 degrees Celsius. The initial temperature of our metal was 90 degrees Celsius. The final temperature of both the metal and the water was 35, and our metal mass once again was 100. All right, so to calculate those, once again, we're going to use negative Q equals Q. And this is the metal, and this is the water. So our negative Q means 100 grams times the specific heat of the metal, which is unknown because it's an unknown metal. And our temperature change, we started at 110, we ended at 30. The temperature went down, so it's negative. So 30 minus 110 degrees Celsius. Our water mass was 56 grams. I knew this. The specific heat of water is 4.184 joules over grams degrees Celsius. And the water temperature started at 25 and ended at 35. Now we're going to do the math for this and figure out what our second metal was. If we look back at our data, whoa, that was weird. Our mass of our water was 56 grams. The initial temperature was 25. The final temperature was 35. So we're going to do negative Q equals Q. Q is going to be the metal. Negative Q is going to be the metal, and Q is going to be the water. All right. We said that the water was 56 grams. We know the specific heat of water because we could look it up, 4.184 grams degrees Celsius, joules over grams degrees Celsius. And our water temperature started out at started out at 25 degrees and ended at 35. So 35 minus 25 for a difference of 10. The metal was 100 grams, and the whole thing is negative, times the specific heat, which is what we're solving for, times the temperature change. And the temperature of the metal started out at 90 degrees and ended at 35 degrees, which is a difference of 55, if I did my math right. All right? So, and it's negative because temperature went down. 55 times 100 would be 5,500. Negative times negative would be a positive. 5,500 grams times degrees Celsius is equal to, where'd my calculator go? 56 times 4.184 times 10, 2343 joules. Now, how do I solve for specific heat? Divide both sides by 5,500. And I get 0.43 joules over grams degrees Celsius. Okay? If we look back at our list of specific heats, 0.43 is pretty close to iron, so we're going to say that that metal was indeed iron. All right, now it's time to do some problems. All right, so imagine, you will, what we've just been doing. We have a piece of lead, that's our metal. We know that we're going to use negative Q of the metal is equal to the Q of the water. All right, the metal's mass is not given. That's what we're going to solve for. So I'm going to put M in for mass. We know the specific heat of the metal is lead, 0.128 joules over grams degrees Celsius. And it tells us that the temperature is starting at 120 and ending at 40. So that would be 80 degrees. The water, mass of the water, because Q is equal to MCAT, the mass of the water is 30 grams. Specific heat of water is 4.184 joules over grams degrees Celsius. And our water temperature starts at 20 and ends at 40. So that's a difference of 20. So let's do our calculations. I'm going to do the water first. 30 grams times 4.184 times 20 is 2,510 joules. Now I'll do my specific heat times 80. 80 times 0.128 is 10.24. So we have mass times 10.24, and our units here are joules over grams. Okay? If we solve for mass, we're going to divide both sides by 10.24. And we get 245 grams. Because grams, the joules are going to cancel. Okay? Our next one, another unknown, or it's not unknown metal. We know the metal. It's iron, but we don't know its mass. So we're going to calculate for mass again. So I'm going to do this down here where we have more space. So let's start. We're going to do Q of the metal is equal to Q of the water. The water mass is 100 grams. The specific heat of water, 4.184 joules over grams degrees Celsius. The water is starting out at 10 degrees and it's ending at 25, which is a difference of 15. The metal, mass is unknown. The specific heat of iron is 0.45 joules over grams degrees Celsius. And our temperature change, let's see if this will work. Sort of. It didn't erase the parentheses, but that's okay. I can do those real fast. So our temperature change, the metal started out at 75, it ended at 25. 25 minus 75 is a negative 50. So mass is going to be equal to 0.45 times 50. And they're both negative, so mass, not equal, I'm sorry, mass is going to be multiplied by 22.5. Our units will be joules over grams because Celsius will cancel itself out, equals 100 times 4.184 times 15 gives us 6,276 joules. Divide both sides by 22.5 and we get a mass of 279 grams. And that's what we were supposed to get. Yay! All right, our third piece, we have aluminum. Again, Q of the metal is equal to Q of the water. The metal's mass is 85 grams. And we don't know its starting temperature, but we know that its specific heat is 0.89 joules over grams degrees Celsius. And we know it's going to have a negative temperature change. The mass of the water is 50 grams. Specific heat of water, 4.184 joules over grams degrees Celsius. And our temperature change, it tells us the change. It doesn't tell us the starting and ending, but that's okay, is 5. We want to solve for the change of the metal. So again, we're going to multiply 85 times 0.89, and we get 75.65. Grams will cancel, so we'll have joules over degrees Celsius is equal to 50 times 4.184 times 5, which all is 1046 joules. Grams cancels, Celsius cancels. And this is times delta T. If we solve both sides for delta T, we divide by 75.65, and answer will be in Celsius. 1046 divided by 75.65 gives us a temperature change of 13.8. All right, hopefully that will help set you up now to do the problems in the Connecting Mastery Chemistry online stuff.